In this video, I will be teaching only the basics of scripting in Godot. If you ever need more details, then use the Godot documentation linked below. Other than that, let's get started. We will be making a simple script for the spaceship that gives us some decently realistic movement. The spaceship is a character body with just a sprite and a collision shape. Go ahead and add a script to the body. For the code I will be making to work, it has to be a character body node. Make sure the template is set to empty, so we can start from scratch. You will first notice that the script always has this line. This tells the engine what class this script is built for. Each node type usually has unique properties that you can modify, and that is why this exists. Right now, it is set to a character body node. This is good, but you would only be able to attach this script to this type of node or any other node that inherits it. For example, Sprite 2D inherits node 2D, which then also inherits canvas item, then node, and lastly, object. That means if we are extending from Sprite 2D, we would have the properties of each one of these nodes. For example, Sprite 2D has a position and rotation, but this is because it inherits node 2D, which is the one that contains these properties, but is given down to Sprite 2D. Next, we will make a function. Function is a method. This is essentially a group of code that can be executed externally by another script or internally somewhere in this script. We will be overriding a method that has been already created by the node class, which is one that we inherit. It is called _physics_process. There is also another one called _process. What these do is they get executed every tick or frame. Process is triggered every frame, and physics process is triggered every physics tick, which the interval is defined inside the project settings. We will be using physics process because we are dealing with physics, and if we were to process our movement out of sync with the physics tick, things can get buggy pretty quickly. Before we can even begin with adding movement, we need inputs that we can use. Go ahead and open the settings and do that. I'll be adding move forward, move backward, turn left, and turn right. We can then add an if statement inside the method checking whether we are pressing forward or backward. If, else, and else if statements are all just conditions to check whether something is false or true, and if so, execute a group of code. And yes, the indents are required when it comes to GDScript. Else gets triggered if the if statement above it fails. Elif is an if statement but is triggered only if the first if statement fails. These can also be stacked, meaning you can do an elif on an elif, and so on. Our code does have a warning, but it's only because we have not used the delta parameter yet. We can easily remove this warning by putting an underscore behind the parameter so it knows it isn't being used. Now, for the conditions, we will be checking for input using the built-in global input singleton, which can be accessed anywhere. We can check for action for whether it is being pressed. Inside the if statement, we can also set up our up and down velocity by setting the velocity variable that our character body has, and changing only its y-axis, which is up and down, and the x-axis is left and right, which we will not be changing for right now. Variables just store information. They can contain a number, text, an array, in other words, a container that also stores information, or a reference to an object. There is more, but in this video we're only going to be going into the basics. If we start our game now, we notice that it still isn't moving. That is because character body only processes its velocity when the move and slide method is triggered. So let's go ahead and add that real quick. Now we notice that it does move, but it doesn't stop moving when we let go. And it is very slow. Let's first add an else statement, so when we are not pressing forward or backward, we will stop. After that, let's boost the speed. Make it easier, just make a variable so we can easily adjust it at any time we want. Let's go ahead and add the ability to rotate the player by changing the rotation_degrees variable. You may notice that when you move forward, it doesn't go where it is pointing. We can fix this by rotating the velocity so it moves along the x and y axis according to its rotation. However, it seems to be a bit broken. It is constantly rotating the velocity. In other words, rotating the already rotated velocity from the last physics tick. We need to reset the velocity before modifying it so that it won't do this anymore. If we use getAxis inside input, we can make our code much smaller. What getAxis does is that it gets two actions. One is +1 and the other is -1. If neither is pressed, we get 0. Because it is such a small value, we need to times it by our speed variable. It makes it nicer to put it into a variable, then add it to the velocity. If you times the value by delta, it will keep the value from being distorted by how beefy your computer is. Delta is the amount of time that went by since the last frame. So this makes it so that even if your computer generates only 20 FPS, it will still be the same value as if you were playing at 120 FPS. As you may notice, it is really hard to control. This can be fixed by making it slow down when you are not pressing anything. The lerp just makes it slowly go from the left value to the right value. And the third value is how fast it does it, between 0 and 1. For turning, Let's make it similar how the forward and backward movement works. Go ahead and add a variable and add it to the rotation_degrees. Now, let's make it velocity based so it can feel more natural. There is a few things wrong. It seems we are adding a bit too much, and it seems to be accelerating really fast. Let's go ahead and fix that. LERPs can be very picky when it comes to what type of number we are using, whether it is a float or an integer. Sometimes you have to define it by putting a period in the number and adding an extra number. Clamps allow us to keep our spaceship from spinning out of control. It keeps a value from going too low or too high, depending on the minimum and maximum values you choose. Let's also make our spaceship have a limit on how fast it can go. Here's the code that does it. The length function gives us a single float, not a vector 2 with an x and y axis, that tells us the true velocity that this player is going. The normalized function returns a vector 2, but it makes the vector 2 true velocity or length to match exactly 1. With this, we can check if we are going over the speed limit, and if so, we set our velocity at 200 or whatever speed you want to be limited to. Next, let's tidy up this turning movement code with the similar technique as the forward and back movement. Nice. Now we got some good spaceship movement code. It would be a good idea to add some comments on the code to make it easy to come back to. I hope you found this video useful. If you'd like to learn something specific about Godot, let me know in the comments. I might make a video on it. Other than that, I hope you enjoyed the video.